There are 5 types of numbers. The natural numbers are also known as counting numbers, 1, 2, 3, 4, etc. Whole numbers are different from natural or counting numbers only because of the 0. We can't count 0 things, but it is part of the whole numbers. Integers are whole numbers and their opposites. So it includes 0, 1 and -1, 2 and -2, 3 and -3, and so forth. But still no decimals or fractions. Rational numbers are where our fractions come in. The definition of rational numbers is the ratio of 2 integers. Basically, that's what we're doing today. Quotients of integers, quotient means to divide. Well, it's going to be the ratio of 2 integers. Now, there are 2 types of rational numbers. When you divide the numerator by the denominator, you either get a terminating decimal or a non-terminating decimal. Now, if it's a non-terminating decimal, it can be a repeating decimal or a non-repeating decimal. If it's a non-repeating decimal, it's called an irrational number. Now, there are famous numbers that are non-terminating, non-repeating. You probably know them as, there's pi, there's phi, and some other ones. Basically the square root of any non-perfect square, like the square root of 2. So those would be irrational numbers, non-terminating, non-repeating. The ones we are going to deal with are the rational numbers. So either terminating or non-terminating. And if it's non-terminating, it's going to have to be a repeating for it to be a rational number. So that's what we're doing today for quotients of integers. They will be rational numbers. So let's do a few fractions, turn them into decimals, and classify them. Let's start off with an easy one that you should probably already have memorized anyway. How about 3/4? Well, on the assignment we're going to want you to show your work on this and to divide it longhand. So the numerator is always underneath the divisor, and then the 4, of course, outside. So 4 goes into 3 0 times, so we need to put down some decimals. 4 goes into 30 7 times, so we subtract 28, that's 7 times 4, remainder 2. We bring down another 0, and 4 goes into 20 5 times. 5 times 4 is 20, and we subtract it with a remainder of 0. That means that 3/4 equals 0.5. Now, which classifications of decimals are those? Well, it's terminating. Wow, this is not working very well. So it terminates. Okay, how about 2/3? Again, 3 goes into 2 0 times, so we write down our decimal and immediately right above it. So 3 goes into 20 6 times, and 6 times 3 is 18, so we subtract 18 from 20, and we get a remainder of 2. So we bring down another 0, and we see very quickly, hey, that's the exact same thing. And I'm just going to keep doing the same thing over and over, getting the same remainder. So it asks, well, first of all, this is a non-terminating. So since it's non-terminating, we now need to classify it either as repeating or non-repeating. And this, of course, is repeating. And then they want us to write it using bar notation. Well, that's 0 point, and we only write the decimals or the digits that repeat, and then put a bar over. This is called bar notation, and that bar actually has a name. It's called a vinculum, and that's kind of fun to say. Let's try a little more challenging one. How about 5/16? So 16 goes into 5 0 times. It goes into 53, because 3 times 6 is 18, carry the 1, so 48. Subtract that and we get 2. Bring down another 0. That goes in once, so subtract 16, leaves you with 4. Bring down another 0. That'll be twice, so that's 32. That leaves me 8. Bring down that 0. And let's see, 80 is double 40, so if I double 2, I get 4. Let's try that. And that is 64. And when I subtract that, go with 7, so 6. Ooh, there's one more. Lucky us. In fact, it goes in evenly. So that means that we're even going to get to be done after this move. So 5. 5 times 6, oops, lost my 0, is 30, carry the 3, 80, so no remainder. So that's it, it's terminating. Alright, let's try one more. Alright, 3 over 22. So 22 goes into 3 0 times. So we put on another 0. It goes in once. Subtract 22. That leaves us with 8. Bring down the 0. Well, I know 22 times 4 would be 88, so it must be 3, which is 66. We're going to borrow from the 8, make that 7. It is 14, so bring down a 0. And 6. Oops. 6 times 2 is 12. Carry the 1, 132. So 8. Oh, look at that. We're right back to this position right here. If I bring down that 0, that's going to be 3 again, to be 66, with a remainder of 14. And then it would be that position again. So that would be another 6, and another 3, and another 6. So this is non-terminating. And it would be definitely repeating. So we need to write it with a vinculum or in bar notation. 0.136. And what repeats? Just the 3, 6. So make sure your vinculum covers only the 3 and the 6. And with a 1, that can be pretty difficult. So maybe make sure that your 1 is big enough. Probably not quite like that. But that is not part of the part that repeats. One last thing I want to mention is about negative fractions. Let's think about like negative 4/5. There are 2 other ways we can write this. Now you can see the negative is in front. Well, that is equal to if we put the negative in the numerator only, or the denominator only. I guess theoretically it would be equal to if we had it in all 3 places. A negative 4 over negative 5. What it would not be equal to is negative 4 over negative 5, because what would negative 4 over negative 5 be equal to? Well, positive 4 over 5. A negative divided by a negative is a positive, but as long as there's only one negative in there, or 3. If there's an odd number, it stays negative. So again, that's not one that we would really use, but if you came across that situation, it would still be equal to all 3 of these. These 3 all go together, these two go together.